right, so we are going to start looking at set theory in relation to Venn diagrams. So in the first two lessons, our entire focus was a lot on vocabulary, what a set is, what a subset is. In the last lesson, some of you may have had your head spinning a little bit, trying to look at some of the notation and trying to figure out the numbers from lists of numbers. Today in this lesson and in tomorrow's lesson, we're going to look at how to take that same information but to organize it using a Venn diagram. So before we even get into some of the notes, I just want to go through a couple demos here. So the first one here, I'm just going to click on the screen and we have a visual here with Venn diagrams. We're looking at volleyball and basketball. So it says in a small Alberta school, there are 14 grade 12 students, and of these students, 6 play volleyball and 7 play basketball. There are 3 students who do not play either sport, and then we're going to create a Venn diagram using that information. So first of all, we know that 3 students do not play either sport. We also know that there's 14 students. So if you notice at the bottom, there's 14 students or 14 people. And so we want to first represent our 3 people who don't play either sport. Okay, so those are our 3 people that don't play either sport. Then we have 14 grade 12 students. We know that 6 play volleyball and 7 play basketball. But if we look at the bottom here, we only have 11 people left. And if I go 6 plus 7, that makes 13 people. So there has to be some people that play both volleyball and basketball. So if I have 11 people left, but 6 plus 7 is 13, 13 minus 11 is 2. So I must have 2 people who play both basketball and volleyball. So if I look at volleyball, I have 6 people who play volleyball. I already have 2 people in the Venn diagram. That means I need a remaining 4 people. All right, so if I look in the volleyball circle or the volleyball oval, I have 4 people who just play volleyball and then 2 people who play both volleyball and basketball. And so if I've set up my Venn diagram correctly, I should still have 7 people who play basketball. So let's check. And so I move those 5 people over. 5 people play only basketball, and then I have another 2 people who play basketball and volleyball. So if I look just in the basketball oval, I still have 7 people playing basketball. We'll go back and take a look at one more example. So we're going to look at a shape sorter. We're going to create our own rules here. And so I'm going to look at a Venn diagram where there's some overlap. And so I'm going to go with triangles. And so circle 1 is going to represent all of the triangles, and circle 2 is going to represent all of the shapes that are blue. So as I start sorting, anything that is a triangle goes in circle 1, anything that's blue goes into circle 2, but anything that's a blue triangle would go in my overlap. So I'll start sorting these. That's a blue triangle, and so on. So anything that's a triangle goes in circle 1, but if it's a blue triangle, it's going to go in my overlap. If it's not blue and it's not a triangle, then it's going to go outside of those circles. And so after I have them all sorted, I can see that all of my blue objects would be in circle 2. So there'd be 1, 2, 3, 4, 5, 6, 7, 8 blue objects. The circles, there would be 1, 2, 3, 4, 5, 6, the triangles. So for circle 1, I'm looking at triangles. There are 6 triangles, 2 of which are blue triangles. And so if I were to ask how many objects are both triangles and blue, my answer would be 2. If I asked how many objects are either triangles or blue shapes, then I would add up everything in the two circles, and that would be my answer. If I said how many of the objects are neither blue nor triangles, then I'd be counting up all of the items outside of those circles. So let's take a look at some more specific examples. You might find it helpful to have either a highlighter or different colored pens when you're making your notes. I'm going to zoom in the screen here. And so we'll look first of all at what a Venn diagram is. You've probably used Venn diagrams in social studies. It's probably one of the more common places to use it besides math. But Venn diagrams are essentially just a visual aid. You might have used them as a graphic organizer in the past. So visual aid, they can be used to illustrate the relationship between sets. So if I give you a quick review here on the last day's lesson, I'm going to define our universal set as any natural numbers less than 20. And subset A would be any natural numbers less than 20 that are divisible by 4. And then set B are any numbers less than 20 that are divisible by 6. So we'll start off by writing out what those sets are. So all of our numbers divisible by 4 would be 4, 8, 12, and 16. All our numbers divisible by 6 would be 6, 12, and 18. Any numbers that are divisible by both 4 and 6 would be 12. And then any numbers that are divisible by 4 or 6 would be 4, 6, 8, 12, 16, and 18. If I've gone too quickly, you can always go back, pause the video, or review that section. But again, that's a review from the last lesson. So we're going to take a look at how we would organize this in a Venn diagram. So we can take those same sets and organize it into a Venn diagram. So any of the elements for set A, those were the numbers that were divisible by 4. The numbers that were divisible by 4, we had 4, 8, 16, and 12. And then all the numbers that were divisible by 6, we had 6, 12, and 18. Now from there, by listing it as a Venn diagram, we can see that the numbers that occur in both occur in our overlap piece right here. So all the numbers that are divisible by both 4 and 6 go in the overlap. In this case, we just have 12. All of the numbers that are divisible by 4 or 6 would be located in these circles. And then any numbers that occur outside of those sets, so the numbers of the universal set that are not in set A or B, are located outside. So that would be that piece there. So that's just a quick refresher of sets, but then also shows how we can use that set theory with regards to Venn diagrams. So this is where you might find it helpful to have different colored markers or highlighter. I'm going to use a highlighter for this. It says in each of the following Venn diagrams, shade the region that represents the given set. So if I'm looking at set A and B, set A would be this piece right here. Set B would be this circle right here. And if you notice as I'm shading, the part that overlaps, the green part, is the part that's both set A and B. So my overlap right here, the part I would actually shade, is the overlap. Okay? That's also known as the intersection because it's where our two circles intersect. If we're looking at the union of two sets, the union of two sets means that it's in something that's in either set A or set B or both. So set A is this here, and anything that's in set B is here. Notice I didn't change my color of pen because it's anything that's in A or B or both. Okay. Now if we want to look at the complement, so if I want to go back and shade here, I'd be shading in that entire yellow section. Now if I want to look at the complement of set A is everything that's included in this circle. So the complement of A is going to be anything that's outside of that circle. So anything that's not included in that circle would be the part that I would shade. So everything in that bright green is everything that's outside of A. So that would be my complement of A. All right, so let's take a look at how this would relate to actual examples. So we're going to go back. We're going to use those same numbers from the previous page. I already have the sets drawn out, but we're going to shade based on the description that we're given. Now, initially I'll write out some of the sets, but eventually I'm just going to go through with the description. So if you're looking at the directions here, it just says to shade the region representing the given set, describe each set in terms of A or B or connecting words. Some I have written out for you, some I don't. And then determine the number of elements in each set. And again, if you remember, number of elements is denoted with the letter N, and then the set is in brackets. So we want to shade set A. Set A is going to be everything that's included in the circle A. And so that would be everything here. If I was actually listing the elements for set A, I would use squiggly brackets, and I would write 4, 8, 12, and 16. Some people find it helpful to just take and draw a circle around that piece. All right, if I'm talking about what the number of elements are in A, if I count up my elements, I have 4 elements in A. If I was shading set B, okay, I'd be shading just the circle B, and my elements would be 6, 12, and 18. So the number of elements in B would be 3. If I was shading the set of elements that are the complement of A, that would be anything outside of A. So I won't list all those elements down, but it would be 1, 2, 3, and so on. Anything that's outside that's been shaded. If I wanted to count up my elements for A, there'd be complement of A, there'd be 13 elements that are the complement of A. Okay, so we can also describe this as the complement of A. Okay, or those elements not in A. All right. Similarly, if I wanted to shade the complement of B, it would be everything that's outside of B. So everything that's outside the circle of B. Okay. So again, I would describe those as not in B, or the complement of B. Notice complement is spelled with an E, not an I. And so the number of elements not in B would be 16. When I'm shading the intersections, I find it helpful, again, to use 2 different highlighters. And so notice I'm using yellow and blue, so where I overlap, I should get green. So if I'm shading all the elements in A, that's that circle there. If I shade all the elements in B, that's that circle there. And where the 2 overlap is my intersection. And so in this case, they overlap here with 12. So A and B would just be element 12, meaning that there's one element that's both A and B. For A or B, it means one or the other or both, so I don't need to worry about using 2 different colors. Anything that's in A, anything that's in B, and anything that's in both of them. Okay. So that again means A or B or both. And so the number of elements that are in A or B or both is 6. We're basically going through every type of example that you could come across with 2 circles. Tomorrow we're going to look at 3 circles. So if we want to shade all of the elements that are not in A and in B, this is an intersection, so again, I'm going to use the 2 different colors. Everything that's not in A is everything that's outside the circle A. Everything that's in B is right here. And so the overlap is just 6 and 18. So this means not in A and in B. Okay, and in B. And so that would just be 2 elements. The next one is a union. A I don't worry about the two different colors. So I'm looking at everything that's in A or not in B, or both. So again, unions, because it's one or the other or both, I don't need to worry about two different colors. So A or not B would have 17 elements. Not A and B. Again, I'm doing an intersection, so I'm going to use two different colors. So this is not A. Everything that's outside of A. And not B. So everything that's outside of B. So if you notice the only part that's, so it's not A and not B. So it's the piece that's green. So it's basically everything that's outside of those two circles that I would be shading. So not A and not B. And that would be 11 elements. If I want not A or B, so not A would be all of this. Again, everything outside of A. Or not B, so shading everything that's not in B. And in this case, the only part that's not shaded is the overlap. So not A or not B, the number of elements would be 18. Just a couple more here. If we have the brackets, it says A and B, and then there's the not. So that means not A and B. So we figure out first what A and B is, and then we shade the opposite of that. Well, A and B is this piece in here. So the opposite of A and B would be everything that's outside of there. So the yellow is our actual shaded piece. And so there would be 18 elements that are not A and B. And if we look at A or B is everything that's in the circles. So not A or B would be everything that's outside the circles. So again, the yellow is the shaded part. And this would be 11 elements. So it's not A or B. Now, if you take a look at these last four examples that we just did, not A and not B gives me the exact same thing as A or B and then the complement of A or B. If I take a look at the complement of A or the complement of B, that gives me the same as the complement of A and B. And so those examples are written here at the bottom. So all of that is just showing you how the Venn diagrams work and how each of these elements would look if they were shaded. But ultimately, we want you to be able to use that in a problem scenario. So we've got a couple more examples here. The first one, we're just going to actually take a look at the Venn diagram and figure out the sets from the diagram. And then we'll look at some actual word problems. So first of all, we're asked to list the different sets. Well, set P, sometimes I find it helpful to actually draw a circle around that set. Set P is everything that's inside the circle P. And so we would have 1, 2, 7, 8, and 9. And for set Q, sometimes it's helpful to use a different color. Set Q would be everything that's in the circle Q. So I would have 1, 9, 13, and 32. If I want to do everything that's in P and Q, that's the overlap between the two, I'd have 1 and 9. And P or Q would be anything that's in P or Q or both. So I have 1, 2, 7, 8, 9, 13, and 32. Not P means everything outside of P. So that would be 13, 17, 19, and 32. Typically, we write our sets in increasing order. not Q. Not Q would be everything outside of Q. So 2, 7, 8, 17, and 19. Now the last few can sometimes get a little bit tricky. If it's helpful, you can always draw a diagram and shade. It says not P and not Q. So it has to be not in P and not in Q. So that's going to be 17 and 19. Again, if that's tricky, you could just draw yourself a separate diagram. There's P and there's Q. Shade not P would be everything that's outside of P. Again, for overlap, we're going to use 2 different colors. And not Q. The overlap would be where the green is. Okay, so everything that's outside of those 2 circles. Not P or not Q would be 2, 7, 8, 13, 17, 19, and 32. So that means it's not in P, or it's not in Q, or it's not in both. Now the ones that are in brackets are sometimes easier to figure out. It says not, then bracket P or Q. So figuring out what P or Q is, P or Q would be everything that's in the circles. Not P or Q is whatever's not in the circles. So we'd have 17 and 19. Okay. And then the last one here, not P and Q. Well, P and Q is 1 and 9. So not P and Q would be everything that's not 1 and 9. So 2, 7, 8, 13, 17, 19, and 32. Now, similar to what we just had in the last set of examples, which 2 pairs of sets are identical? Well, G and I are identical, and H and J are identical. So G and I, and then H and J. Okay. Now, that example that we had there was showing a set of numbers that had been arranged in a Venn diagram, but we can also just use a Venn diagram to represent the number of elements. So here would be an example that we can use that just represents the number of elements rather than each individual student. So the question says the diagram displays the number of students who are members of student council and the number of students who are on the yearbook committee. So we have student council, and again, when I'm doing these questions, I find it's helpful to use colors to distinguish between the 2 circles. So we have student council and we have yearbook. And notice there's an overlap in the middle. That would be our students who are on both student council and yearbook. So it says how many students are on student council? Well, student council, I'm just going to erase these here. Student council is all of the students that are inside this blue circle. There's a tendency for us just to say 15, but in the entire circle we have 15 plus 3, which is 18 students. So there's 18 students on student council. Now how many are on both student council and yearbook? That's going to be our overlap, which is 3. If I had asked you how many people were on the yearbook committee, if I'd asked you how many were on the yearbook committee, it would have been 3 plus 8, which is 11. Part C says how many students are on the yearbook committee but not on student council? Well, we have 11 people on the yearbook committee, but we have 3 people that are on student council. So 11 minus 3 is 8. Okay? And notice that's the number that was in just the Y part of the circle and not in the overlap. And then the last question says how many students are on student council or yearbook committee? Well, or means one or the other or both. So that's going to be both of these circles. So we'd add all those numbers up. 15 plus 3 plus 8. Now in this particular question, there were numbers in all the circles and everybody was represented as either student council or yearbook. We can get into questions as well where there's a number in the universal set that's outside of those circles, and that would represent the number of students who were not on student council or yearbook. Okay? And so we'll look at some of those here right away. So often you're going to be given a question where you're just given the information and you need to set up the Venn diagram yourself. The outside box is going to be the universal set, and then the individual circles will represent your subsets. So this question says, in a homeroom of 20 students, 13 take math, 11 take social, and 8 take math and social. So we're going to represent this in a Venn diagram. So one of our circles is going to be math. One of our circles, again, it might be helpful to use a different color. One of our circles is going to be social. And then we have the box around it that's our universal set. So 20 students we have 20 students total, 13 taking math, 11 taking social, and 8 taking math and social. So whenever we're setting up these questions, it's really important that we start with our overlap. So we have 8 students taking math and social. If we have 13 students taking math, everything in that blue circle has to add up to 13. We already have 8 in that circle, so we're going to need another 5 to complete the circle. So how did I get that? I went 13, take away 8, and that's how I got 5. Now for social studies, I have 11 students taking social. There are already 8 students in that green circle, so the remaining number would be 3. And again, I got that by going 11, take away 8. Now, at this point, a lot of people will say, okay, I'm done, I got everything filled in. But we have to check, does this add up to 20? If we add up 5 plus 8 plus 3, that only gives us 16, but we need 20 students. So that means there are 4 students that don't fall into either of those categories, because 20 take away 16 is 4. So when you're done doing the question, you need to go back and double check that all of the numbers add up. 5 plus 3 is 13 taking math, that's good. 8 plus 3 is 11 students taking social. I had my 8 students taking math and social, and if I add 5 plus 8 plus 3 plus 4, I get 20, so it's all good. And then from there, I could ask you a whole bunch of questions, like how many students take only math? That'd be 5. How many students take only social would be 3, and so on. Let's take a look at another type of example. In a survey of 400 households, 285 had digital video recorders or DVRs, and 320 had multifunction printers or MFPs. And then 63 households did not have either. So that's the easiest one to fill in right away. 63 don't fit into either category. Again, if you find it helpful, you could outline your circles with different colors. X is going to represent the number of households that have both a DVR and an MFP. So we're told D stands for DVR, M for MFP, and X stands for the number of households with both. So we don't know what that is yet. But we can use our Venn diagram to figure out all of the missing information. If I wanted to write an expression for the number of households that have DVRs but not multifunction printers, that would be everything that fit into this circle. Well, I know, based on the question, that 285 people have DVRs, but I don't know how many people have both. So this is going to be 285, take away however many people have both. So 285 minus X. For the multifunction printers, I know that 320 people have the multifunction printers. That would be the M circle. I don't know how many have both, so this is going to be 320 minus X. Once I have all that information filled in, then I can use everything I know, and there's still an amount I haven't worked with yet, the 400, the total of 400, to figure out how many people had both. Now, I'm going to show you this as an equation. You can write it as an equation, but often it's easier just to use your Venn diagram to total up all of your numbers. So I know that 285 plus 320 plus 63 plus all of those X's has to total up to 400. So I can write it out as an equation. I can write out that 285 minus X plus 320 minus X plus the 63, that's one that we often forget, equals 400. We simplify by combining like terms. So 285 plus 320 plus 63 is 668. A negative X and a positive X cancel out, and I'm left with a negative X equals 400. Again, I'm writing it here as an expression, but I find it easier just to look at the Venn diagram, add up your numbers, add up your X's, and then set it equal to 400. 668 minus 400 equals X. And so X equals 268. So my overlap here is 268. And once I know that, I can ask you lots of questions. How many students or how many people had only DVRs? Well, that's 285 minus 268. How many people had only multifunction printers? Well, that's 320 minus 268. How many had DVRs or MFPs? I could ask you that as well. So hopefully that gives you enough information on how to set up your Venn diagrams. Once you have the diagram set up, everything else is just reading and interpreting to answer the questions. If you have any questions, make sure you ask me in class tomorrow. Good luck and have a great night.